Hi everyone, it's Sam from Retrotec, and today I'm going to talk about how to do some basic equipment maintenance to make sure that your fans, your manometers, and your tubing are working the way that they should be. This is what's called a field check to make sure that your manometers and your fans are working the way that they're supposed to be if they're fully calibrated. So you can't do calibrations yourself, but you can do a field check to make sure that the fans and gauges are still working within calibration. So first we'll start with the manometer. This is the DM32 Smart Gauge from Retrotec. And the way that you can check this gauge, you can check one side against the other. So this is what's called a two-channel manometer. So it's actually two manometers built into one. So we can check channel A against channel B to make sure that it's reading properly. And the way you do that, there's 4 different configurations that you check. So we'll start off with the blue port. We'll put one end of our yellow tube from our umbilical on the blue. And we'll start with the yellow on the other side on channel B. So as you can see, I built up a pressure to a little over 300 pascals here. And what I want to do, I want to make sure that I'm reading pascals on both channels. So I'll switch this from EQLA to pressure. And now you can see it's reading roughly the same. The way you want this to read, you want these two numbers to be within 1% of each other. So both of those sensors on both sides of the gauge should be working the same way. So this one's only 1 pascal off, so that's well within our 1%. And so we'll just repeat that with different ports. So we'll switch this one from yellow to green. Let it stabilize. And we're getting about the exact same reading there. And so now we've checked our blue against the yellow and green. Now we'll switch over to red on channel A. It's good to keep your tubing still while you do this so you don't have it swinging around. We're getting the exact same pressure there too. And then the final configuration is red versus yellow. There, that's looking good. So next we'll look at motor alignment for the blower door fan. So what we'll want to do is pull off the B8 plate, and then we'll want to take off this outer ring A as well with these 4 bungees. And then we'll lay the fan on its side. We'll have the inlet side facing up. And essentially what we want to do is lie a straight edge across. There are 2 areas on the diameter you can see here where the kind of the marriage joint for the fan shell. You can just line your straight edge. I'm using a yardstick here. So ideally what we want is when we put this straight edge across the diameter, we want to see a 1/8 inch gap between the bottom of this straight edge and the label in the center of the nacelle. The nacelle is this yellow piece in the center. So if I lie my yardstick across here, it actually hits the label on this fan and it gives me a gap over here on the edge, which is what I don't want. And I know for this particular fan, this is the one I use to ship to trade shows and training events all over the country, so it's been jostled around quite a bit during shipping and hasn't been sent back to the Retrotec lab in a few years, so I'm really not surprised to see that. So if you're one of those people that ships your fans to a lot of job sites, this is an important test to do on your equipment to make sure that it's in working order. Just to look at motor alignment. And another thing as far as alignment goes, we can also look at the tips of the fan blades to see how far they are away from the inside of the fan shell, because we want a 1/8 inch gap there also. So if I take a closer look at this fan at the tip of the fan blades, I can see that I have less clearance down in this portion of the fan shell than I do up here. So that means this motor got knocked around a little bit down to this region here, which will affect my readings and will affect the amount of flow that I get too. So every now and then, especially if you have guys on your crew that are tough on the equipment, take this screen off and measure around the fan blade tips there to the fan shell to make sure you have that proper clearance of 1/8 of an inch. Next, we'll see if we have any leaks or blockages within the tubing that's built inside the blower door here. So on the inlet side of the blower door, our fan pressure is measured in these 4 points right around the nacelle where you see these fins protruding out. Between each set of fins is a very small hole that are then connected to an airtight piece of tubing inside here, which then goes up and meets the yellow port on the side of the fan where the manometer is plugged into. So the way we check that is with silly putty, of all things. We take that out, and we want to use silly putty to clog up all 4 of these holes. Once we have our silly putty installed here, we'll notice that it builds a pressure up inside of the tubing and inside of the fan itself, which is a good sign. That shows us that we don't have any leaks. And so to check to make sure we don't have any clogs, we'll just remove each piece of silly putty one by one and then replace the one we take off. So if I take this one off, we should go down to 0. And there we go. So that means we don't have a clog on this one, so we'll put that silly putty back. And then we'll continue to work our way around the nacelle until we finish them all up. That's how we make sure we don't have a clog inside of the system. And it's important to use silly putty and only silly putty. Don't use Play-Doh, don't use clay. Silly putty is the only material that will go into these holes and then come back out in one piece and not leave it clogged. So it's important, if you're going to do this, only use silly putty. Another test you can do on your blower door fan is to run it wide open with all of the rings off, and what you're hoping to get is a pressure within 15% of 142 pascals. So we'll hook it up just like we would to run a blower door test. We just won't use the red tube. We'll hook up our yellow tube to the fan, to the yellow port, same thing to the gauge. And again, we'll have our gauge set to the fan wide open, and then we'll crank it all the way up. And if you do it on a tabletop like I'm doing here, be sure to keep a good hand on it because it will take off and move away from you. So make sure you have a firm grip on it. So with the reading that we got from that test, we could see that we were well within our 15% range of that 142 Pascal target that we wanted. So our pressure that the fan generated was pretty good. So next we'll look at some tests we can do on our DucTester fan. This is the 340X. This is the newest model of the DucTester that we have. It's the model that has the plate on it so that you can stick your manometer on there to keep it off the floor so nobody steps on it. But as far as motor alignment and fan blade alignment goes on this model, as long as you don't hear anything hitting on the inside, it's good to go. Instead of an axial style fan like the blower door uses, this uses a centrifugal blower, more like you see on the inside of an air handler. So a totally different fan type. So like I said, as long as you don't hear it bumping or rubbing up against anything, it's good to go. But it's a similar process when we talk about finding leaks and clogs on the inside. So on this fan, as far as pressure readings are collected, on the DucTester we have the yellow and green inputs here. So on the inside, you'll notice that there's 8 tiny holes. That goes to the yellow. And on the outside, we have 4 tiny holes, which is where pressure from the green port is collected. So if we're going to look at the yellow, what we'll do is we'll just use the blue port on our manometer and hook up the other end to the yellow. And then since this is a smooth plastic surface, we can just use painter's tape or masking tape to go over this. If you have the older model, the DU200, you'll notice that it has a textured plastic on the inside here. You'll want to go back to your silly putty to use that there. It may seem like you can get a good seal with tape on that, but you can't. It's got to be one of these newer models that has a smooth plastic on the inside if you're going to use tape. So I will just go along and tape up all 8 of these holes and make sure that I get a good seal all the way around. So now that you can see by doing this, I have built up a pressure inside the tubing here. So that's a good sign that shows that I don't have any leaks inside the assembly between where the pressure is picked up at those holes and where I plug my manometer into the port on the side of the fan. So that's a good thing to see right off the bat. So just like the blower door, I'll go around and I will untape each piece, each hole one by one to make sure that I don't have a clog in any of those holes. So if I release this one here, I should watch this go back down to 0. And then just like the blower door, I'll patch it back up and then move on to the next one. And I'll do all 8 of these holes just like this to make sure that they're all free and clear of debris. So now I will unplug my tube from the yellow port, and now I'll check out the green port. And again, pressure is collected here right along the outside. And if you look and see, if we look around the edge here, you'll see that we do not have a smooth surface to tape to. So we're back to using our silly putty. So again, we have 4 holes here. So we're going to just break off a small piece. This kind of looks like chewed up chewing gum. But we'll make sure we plug those holes up as good as we can so that we can build a pressure inside of our gauge. So now we've built our pressure up, and just like we've been doing, we're just going to release them one by one and watch it go back down to 0. Patch it back up to build a pressure again, and then work our way around the fan. This next test that I'll show you will help verify that if your DucTester is getting the correct flow reading. So this is where you have the system hooked up just like you're going to do a duct test and have your flex stretched out just like so. This involves using a calibration plate that's put on like so. It's taped on to the clear flange at the end of the flex. So you can just use painter's tape just like I'm using here to get a good seal around all of the edges. And once we're all taped up, we have a blue port here on the plate, so we'll go ahead and attach our blue hose to that, and then we are all ready to go. That's what's going to be reading our pressure inside of the flex. And so to run this test, we can do a depressurization or pressurization test. Range 74 on this is just fine, just like we have it set up here. Again, with that flex stretched all the way out. And on the plate itself, if you look here, there's a sticker that tells you what target we're looking for. So here, as you can see, we're set up to do this test in pressurization mode. So the target we're looking at is 104. So now that we have everything set up, we have our gauge on. We'll go ahead and make sure that it's on the setting for the Model 340. And now we are all set to run the test. So I'm going to use our gauge remote app here to make the screen a little more visible, and we'll go ahead and kick it off. So by using the at feature here on the gauge, we can see at 25 pascals, we're getting pretty close here to our 104 mark. And the closer that it'll get to 25, the closer it's going to get to 104. So as long as we're within 5% of that target of 104, that DucTester is doing just fine. So this fan seems to be doing what it's supposed to. And if we wanted to test in the depressurized direction, all we would have to do is just pop that flex off using the quick connect collar and then snap it back onto the opposite side, and just like that it would be ready to go. And then on this side our target pressure would be, or I'm sorry, our target flow would be 98 CFM. You can do a similar test for your blower door by taking a rigid material such as a piece of plywood like you see here, or a piece of foam board, and cutting out a 12 by 12 inch hole into it that's a square like you see here, and using your EQLA function in square inches to get the reading. And you install the board above the blower door frame like you see here in the photo, and then you run your blower door test with the hole open, and you record your reading, and then you run the blower door test again with the hole covered up and record that reading, and then you subtract the second reading from the first, and the answer should be 144 square inches, since that is the area of the hole you have in your board that's 12 by 12 inches. So that's just a similar test that you can do to test to make sure that you're getting the right readings on your blower door fan. Another thing I want to talk about is the tubing in your umbilical. Sometimes by accident you can get water or debris lodged in here, and that can make you or break you in the field. Especially if you have water in it, definitely don't blow on it. That can add more moisture, and especially don't blow on it if it's hooked up to a fan or a manometer, because that can really mess up your equipment. If you do get water or debris in it, the best thing to do is to sling it out and then just hang it up to dry. That's why it's a good idea to have an extra umbilical of tubing and data cables on you when you're in the field, in case that happens. That way you can pick up and keep going. Another item that's worth noting on the DucTester and blower door fans is the status light. So you can see here I have my manometer plugged in. It's using the data cable, and we have a steady green light. But if I were to disconnect it, you can see that it starts blinking red right here. And what that means is that it just doesn't get a signal from the gauge. So for example, if you were to have your gauge plugged in and everything hooked up properly, and you are still getting that red blinking light, chances are that means that you have a bad data cable that needs to be changed out. So one last thing I'd like to show you is if you set up your blower door and your gauge, but you mismatch the setup. So for example, I've got ring A on my blower door fan, but I'm going to leave my gauge wide open on that setting there on purpose, just to show how you can get the right reading later on if this ever happens to you. So if you get back home or get back to the office and realize, oh man, I did that wrong, there's actually a tool that you can use to go back and see what the correct reading would be. So with the fan on ring A and the gauge set on open, I'm going to go ahead and run my blower door test just to see what incorrect reading I get. So on this I got around 3,700 CFM 50. But now what I'm going to do is go back to my laptop on my PC and open up our virtual gauge program. That way I can play around with the pressures and change the settings to see what the flow actually is, how to run that test correctly. So what I'll cover now is how to get a correct reading from a blower door and manometer that were set up incorrectly using our virtual gauge tool. So as you see here, if you haven't downloaded virtual gauge already, you can do so on our website. If you just click on software and scroll down, you'll see virtual gauge here, and you can just download it. It's free, it doesn't cost anything, and it's a pretty handy tool to have. And so basically, once you open it up, it just gives you this screen of the DM32, and then you can click on this gear that opens this drawer up, and then you can input pressures for channel A and channel B. So if we look back at our blower door test that we did before, where I ran the test on ring A on the fan and then had it open on the gauge, let's try to recreate that, and then we can change the fan setup to where it would be correct to see what our flow would be. So I can see here on my iPad screen I had it at negative 51.2. So I can go ahead and enter that in first. And we see it pop up on channel A. And one thing I need to go ahead and mention, you need to do this step second. The first step you do is just to go ahead and get the range set up incorrectly as it was in the gauge when you did the test. Make sure you do that first, then input your pressures. Otherwise, it'll just go back to default. So step one is to make sure you're on the right range, or I guess wrong range that you did in the field that day, and then you input your pressures in. And so the tricky part is trying to get the right pressure for channel B. This takes a little bit of toying with. The thing you want to be able to get is that flow that you got incorrectly on the gauge. And so if I look at this, I'm seeing 3691 CFM. So I want to try to get that on channel B. So let's just put in 50 pascals just to see what we get. Okay, so that's a little above what I want. So we'll go down to 45 and see what it is there. So I want 3691. That's a little low, so let's try 46. Getting warmer. Let's try 46.1. Boom, close enough. So 3691 is what I got in the field. So I'm at 3692 here. That's a close enough reading. So now I'm going to change my range to ring A, and 1964 is what I would have gotten if I would have done that test correctly. So if you've ever run into this issue in the field, there is a way that you can backtrack and see what that reading would have been. This is a really handy tool to have for that reason. There are charts that you can use to go back and do it, but I think this is the easiest way. I'm a visual learner too, so I'd like to see it replicated on the tools that I use. If you ever run into that issue, give this a download and try it out for yourself. That wraps it up for the calibrations and field check video. If you have any more questions about how to maintain your equipment, what you should and shouldn't do with certain tests, reach out to us and let us know. Call our tech support team, shoot us an email. We have plenty more videos here on YouTube that goes through certain topics. So thanks for watching.